Hello, here I will show you some of the basic capabilities in Kognitwin's Net Zero environment. So as we see here, we are working on several fronts, looking into various net zero relevant industries and sectors. But today I will mostly focus on measure, report, and reduce as three of the pillars in our product. So starting off with the measure part, just to show you some of the basic capabilities we deliver here. I made just a generic PNID type of document to show you some of the flexibility in our system. So as you could see here, we are measuring various emission sources. It can be like venting type of emission sources, more rule of thumb based. If you have a vessel or tank and you have a pressure transmitter, you could say something about how much do you vent from that tank. If you potentially have a kind of emission related atmosphere within that tank, that could be relevant to have a look at. Of course, not physical metering, but still good to capture some more detail than only kind of this very known, for example, on flaring, where we very easily can transfer the flow transmitter, combine that with the composition of the gas, either measured or kind of model type or a modeled composition based on your process parameters, transfer that into CO2 equivalents, and of course store that and be able to report that very efficiently. Some known but hard to capture, or at least precisely capture on a lot of facilities, seal gas emission from compressors. You could combine kind of the sensors and data sheets and metrics you have in place around your compressor to say something about the most likely typically methane and other types of hydrocarbon emission you have out from the seal, and transfer that back to, for example, CO2 equivalents, if that's what you mainly are measuring on or reporting on. And also stripping gas, for example, where you have also a non-physical meter that you could very easily transfer that into, based on the data you have in your system, do the best type of assumption that is possible to do in terms of what will be the relevant emission to measure there, and keep overview of that on the process value that is affecting that directly or indirectly. So you could set up a model for that, so you don't need to do a lot of manual work and download a bunch of data to back calculate this on a monthly basis or something like that. We could have that in real time, and of course automate the rest of the reporting and the optimization possibilities within each of these various emission sources. And we also have a pretty strong library of models, physics-based models that you, for example, based on a pressure control valve with upstream and downstream condition, could estimate the flow through parts of the system where you don't have a flow transmitter, for example, and link that back to potential emission sources, more like indirectly, like this tank example or a separator example, where it could have a venting type of emission or other relevant factors that you want to track over time to see if you can improve, or at least be aware that you have an emission source that is hard to measure with the more classical approaches to emission management. So I can also show you a real example of how we do this flow estimation with a proper physical model. And we combine both first principle models and machine learning models to do these estimates based on the best approach for each case. So here we see more of a real plant example. So here we have a flow transmitter before we split the pipe into two segments. So parts of the flow go up and to the right, and some continue straight forward, so to say. So here we have built a model to estimate through this LV and FV flow valve and level control valve to base on both kind of the data sheets and design, and also on physical principles. So on the right here now you see the model breakdown in kind of how that is split up, and the various kind of physics-based sensor readings and machine learning models that go into the calculations. So for some example, we only do physics-based, and sometimes we do a combination based on what we are after in terms of information and output of the model. So here we see we only calculate the flow because that's the relevant example to look into here. But this is of course also something we could utilize in terms of emission sources to have kind of as advanced calculations you need and how many input parameters you need. That's pretty much 100% flexible. So it's not limited to taking like one transmitter and converting that into emission source. This is the basic functionality within our measure capabilities, and now we will take a look at some of the reporting functionality. This is an example of one of our emission dashboards, of course highly configurable. This one is based out of Power BI, but we also have embedded dashboards within Kognitwin, and could also have API connection to other systems if that's what you prefer. So also on the dashboarding or reporting side, very flexible. So of course with Power BI you have some flexibility in drill down into looking at emissions on various time scales. You can trend your emissions over time to see how it develop. You can see your current emission numbers, and of course it's possible to have multiple KPIs and various relevant metrics up on a dashboard. If you have a broader portfolio, it's easy to split that up and have a breakdown type of structure there to see how your emission is evolving over time, and be in 100% control over your emission in a reporting perspective, either to kind of governmental type of reporting or more on a business type reporting. It's easy to split up, and we could have multiple views and various analysis based on the raw data that both is kind of tied together within Kognitwin, and also made in terms of models and other types of approaches, for example from the measure capability as we just saw with virtual models, combination of real-time data, machine learning, and other approaches based on what type of setup you have and what makes sense for your business. The last part we will be discussing today is about reduction or optimization in terms of emission management. And just to talk around some of our capabilities, we have just set up a very simplified model here based on the emission sources that we saw earlier here on this flow diagram. So you have the kind of separator venting emission, we have the compressor seal gas emission, the stripping gas emission from regeneration, and we have the flare system, the low pressure flare system in this example, the emission from that. So these boxes or cards on the left, they are representing models that we base our kind of output formats on. And as I touched upon earlier, it's very flexible, and they are following a standardized data language for modeling called ONNX. So you could base that on physics, first principle type of approach, purely on the machine learning models within this framework, or a combination, as we typically name a hybrid approach. So then, of course, you could pull in the measured data from your real-time system directly and utilize that to have the model running to output the various emission sources, as we see here, but also go into calculation of the total emission number in various kind of production modes, or other type of what if analysis that you want to do. So then you can switch in, like, if I do this change in my plant, then the model runs, and of course you can have a much more intricate setup than this, that one change in part of the facility will of course also affect other parts, and we could tie all these relationships together to then both, like, how do I need to operate now with the current production from a reservoir, or with whatever back pressure on the export pipeline, or other relevant factors? How do I need to set up my plant to, of course, take care of the optimized production and low kind of energy inputs, or various factors that go into your production, or whatever type of facility you are looking at. Or it could be much more towards, like, I will only like to see how I could optimize or reduce my emission sources. So if I switch from 3 to 2 export compressor, what happened with my emissions? Or if I lower the pressure in this part of the facility, how will that affect the relevant emission sources along those systems or subsystems that are affected by that, and see those types of things very efficiently. So this is what we call the emission calculator type of functionality, and but we have a pretty wide set of tools and modeling capabilities that can do much more advanced type of optimizations as well. But this type of what if scenarios are pretty efficient and very quick, because the kind of models are very contained and they are small in themselves. So it's kind of, each calculation is very fast. So it's just about setting up the right kind of network and or topology between the models to be able to be efficient and really see what you can do in an efficient way to lower your emissions. And of course, that will be reflected immediately on your reporting or dashboard to see the performance there.